regarding the physics aspect of the UTME, we'll be so much surprised with the nature that JAMB will be telling us to look for cos 60 degree, cos 30 degree. And the type of calculator given to us is just a market calculator that we cannot solve. We cannot use very well. Now, how do we do in what in this place is that when God gave us hand, He gave us hand for some purposes. How do we do? Take, JAMB is not criticizing you. When you draw your hand in your solving booklet, when you draw your hand in your solving booklet, it's just for you to be able to calculate some concepts. Now, in this now, let's name this 0 degree, we have 30 degree, we have 45 degree, we have 60 degree, and we have 90 degree. Now, these are what we call the special angle. And in this special angle, we need to take note of sine, we need cos, and we need tan. Now, let's take, because the angle, it is from the product or the division of the sine and cos that we are going to get our tan. The angle is divided into two, one for the sine and one for the cos. Definitely, whatever we are going to do in this plate, it is going to be divided by 2. Now, example, I want to determine, find sine 30 in your sine 30 degree. In your UTM, you are calculating, let's say you are calculating for velocity ratio. And you come across a question where say velocity ratio is the angle of the inclined plane is inclined at 30 degree. Now, you are not finding what is sine 30 degree. You don't know, just draw your hand on your answer booklet or your calculation booklet. Now, if it is for sine, you count towards the right. Towards the right hand side. Towards the right hand side. Now, sine 30 degree, you shade it like this. Sine 30 degree, you shade it. Now, look at it. How many fingers you did not shade towards the right side? You will find out that it is just a single finger you did not shade. Therefore, you will now say that finger you did not shade, that is what? The square root of that finger. That is the square root of 1 all over what we have. I say whatever we get divided by 2. So we are going to have root 1 is 1 all over 2. If you press your calculator, you are going to find that sine 30 degree is equals to 1 over 2 and it is equals to 0.5. Now let's come again. Sine 60 degree. This is 60 degree. You shade it. How many fingers you do not shade? When we are talking about sine 60 degree now, we have 1, 2, 3. That is, you do not shade 3. It's going to be root 3 over. Remember I said you are dividing everything over 2 divided by 2. If you press your sine 60 over 60 degree, it's going to give you root 3 over 2. Now let's come sine 90 degree. Sine 90 degree. We are talking of 90 degree. You shade 90 degree. How many fingers you do not shade towards the right? 1, 2, 3, 4. That is 4. Root 4 over 2. Root 4 is what? 2 divided by 2. Therefore, sine 90 degree is equals to 1. So you can do for sine 45 to save now. Now, let's go to that of cos and cos theta. If I'm having cos 30 degree. Now for cos, it is the opposite of sine. You know, for our sine, we are counting towards the right hand side. While for cos, we are going to count towards the left hand side. How do we do this? Cos 30 degree. Now, towards the left, how many fingers? 1, 2, 3. Therefore, we do not count for what? 3. It's going to be root 3 over 2. If you look at cos 30 degree is equivalent to sine 60 degree. That is because sine 60 degree is also root 3 over 2. Now let's say cos 60 degree. Cos 60 degree, you shade your angle of 60 degree. How many fingers we do not count? Towards the left hand side, it's just 1. So we have it to be root 1 over 2. So we have this place to be 1 over 2, which is still equivalent to sine 30 degree. Now let's come cos 90 degree. Cos 90 degree is that we have this, we shade this plate. You can see there's no any finger towards the left hand side, so we have no finger. That is what? 0 divided by what? 2. And if you press 0 divided by 2, it's going to give you what? 0. If you press cos 90, it is equal to what? 0. Now, how do we now determine that of the tan? Because we said we only divide the angle into 2 and not what? 3. How do we go? We have tan angle. Tan theta is equals to sine theta over cos theta. Now, I want to determine tan 30 degree. It is going to be sine 30 degree over cos 30 degree. Now we come now, our tan 30 degree will now be equals to, what is our sine 30? Our sine 30 is 1 over 2 divided by our cos 30 is equal to root 3 over 2. So what we press, we say sine 30 degree is equals to 1 over 2 times 2 over root 3. This will take care of this. Tan 30 degree is equals to 1 over root 3. Now let's take tan 60 degree. It's going to be sine 60 degree over what we have cos 60 degree. Now we now have that our tan 60 degree is equal to sine 60 that we calculate is what? Root 3 over 2 divided by what is our cos 60 is what? 1 over 2. So we have that tan 60 degree is equal to, we have root 3 over 2 times 2 over 1. So this take care of this, we have it to be equals to root 3. So tan 60 degree is equal to root 3. So you can do as much as what possible. So this shows us that this is how ETN is going to what to proclaim is what is question. So for those of you who have been asking that how do we solve angle in what? In German, the calculator given to you people, it's just a normal calculator. So this is how you are going to do with it. God bless you so much. Now let's look at a little dimension of what we call mirror formula. In a mirror formula, I'm not going to dive on this very well now, but I just want to give us a what is slow step. In mirror formula, actually you people, you have learned a lot on this, but a shortcut for whatever we want to solve. In mirror, we have what we call two types of mirror: concave mirror and we have convex mirror. Now, what do we mean by concave mirror? Concave mirror means that all the rays of light that are coming, all the rays of light that are what? Coming, they are converging. They are converging. While convex mirror, all the ray of light that has already converged in a particular point, they are now diverging. That is, they are moving to different what points. Now, in this mirror formula, what we need to take note is that we have what we call the V. What is our V is what we call the image distance. We have what we call our U, object distance, and we have what we call our F is also called the focal length. The focal length. Now, when we have this, there is what we call the concave mirror and what the convex mirror. Now, what you need to take note is that a question under this place is they are going to tell you that an object is placed in front of a concave mirror, is placed in front of a convex mirror, is placed behind it. How do we solve this? If it is for concave mirror, now, if it is for concave mirror, automatically our F is positive. Concave mirror, automatically our F is what? Positive. Now, what do we use our focal length is what to determine is that if they tell us if it is concave mirror or convex mirror. If it is convex mirror, our F will be equals to negative. Now, if in our position of the object in front of the mirror. In front of the mirror, we are going to have our u to be equal to positive, and behind the mirror our u is going to be negative. Now, if you are able to establish these 4 points in your question, you are good to go with any question in the mirror formula aspect. Now, look at this place now. If I'm having a question that an object is placed in front of a concave mirror, automatically my u is equals to what? Positive. In front of a concave mirror, definitely my f is also equals to what? Positive, because it is in front and the what? Concave mirror. But then I say I should calculate the what? The image distance. My formula I'm going to use is that v is equals to u multiplied by f all over u minus what? F. Why is this place positive in front of the mirror? Concave mirror means that the focal length is what is positive, and then you say u minus what? F. So we take this one first. 1. Number 2, if I say an object, okay, let's put in front of the mirror, and here we have concave mirror. Now, number 2, we have u is equals to minus what? Minus, that is, it means that it is what? Behind the mirror. If my f is equal to what? Positive, this means that it is what? A concave mirror. Now, f is what? Positive. Automatically when f is positive, it means that it is a what? A concave mirror. Now we want to calculate our image distance unknown. Is going to be v. What is our u? Minus u times what? F all over minus u minus f. You know, because why is it minus? Because it is what? Behind the mirror. So it's only this thing that want to change here is that we have negative in this place and also negative in this place. Now, 3. If I have my u to be equal to positive in front of the mirror, and I'm having my f to be equals to negative, that is a convex mirror, my v will now be equals to what we have. V is equals to, we have it to be u multiplied by what? Minus f, because it is a convex mirror, divided by u minus open bracket minus f. You know, automatically it is what? U minus f. But now the focal length is now a negative because it is a what? Convex mirror. What are we going to have? This is going to be minus uf over u plus f. That is for a what? An object in front of the mirror, but the focal length, the nature of the mirror is a what? Is a convex mirror. Now number 4, we have u is equals to negative, that is behind the mirror, and our f is also what? Negative, that is a convex mirror. Now what do we do here? Our v is what? Is unknown. Now what do we have there? We have our v is equals to minus u times minus f all over minus, we have this one to be what? Minus u open bracket minus open bracket minus what? F. So what do we have here? This one minus times minus is going to be what? Plus uf all over minus u plus f. So this is when the object is behind the mirror and the focal length is a what? Is a convex mirror. Now take note, our concave mirror, you know, we said it is what? Converging. It's equivalent to convex lens. This is where usually we trick most of students. Our convex mirror is equivalent to what we call what? The concave lens. Now, you see, this our concave lens and this our convex lens. Our convex lens is used to treat long-sightedness. and that is what we call hypermetropia. And our concave lens, it's used to treat short-sightedness, known as the word the myopia. So please take note of this. Don't confuse. Concave mirror is also known as what? Convex what? Lens. Because both of them, they are going to what? To converge. While convex mirror is also known as the what? The convex lens. Both of them are going to diverge. In our next class, we are going to bring sort of question to solve under this principle of mirror formula, and then we're going to tell ourselves where is the position of image is going to form, and also what is magnification. Thank you very much.